How's it going? My name is DKArnold. I'll be going over our controlling microbial growth presentation here. I've got all my notes written down on a Word document here to the right, so bear with me as I'm going back and forth. So in regards to controlling microbial growth, we know that we have a variety of different options to go about doing that, whether that's public or private or at home or in a healthcare setting. Four of those topics are disinfection, sterilization, sanitization, and antisepsis, and I'm going to kind of go through them one by one here. So we'll start with disinfection. This is the use of physical or chemical agents that are used to kill all pathogens except for endospores due to such extreme environments that they do live in. Now that includes that, so that does mean they can kill almost all viruses as well. Now, the chemical agent that's used in disinfection is called disinfectants, and versions of this are UV light, heat, alcohol, and bleach. Now, with disinfection, it is used on inanimate objects, so it's not used on our skin or any other tissue. And this is correlated to some of the intensity of some of these chemical agents that are used. Now, it is more concentrated than an antisepsis or a sanitizer and can be left on the surface for an extended period of time, okay? Also, it can be found in forms of sprays, wipes, or liquids available to the public. And what can be found in these examples are phenol, alcohols, and soaps. And we're definitely familiar with the last two for sure. Now, the next closest option for controlling microbial growth closely related to disinfection is sanitization. Now, this is the process of disinfecting plates and utensils used by the public to reduce pathogenic organisms. Now, both disinfectants and sanitizers are used on inanimate objects. Now, the biggest difference here is sanitizers do not kill viruses. Their goal is to decrease the bacterial load on objects, but they do not kill viruses, and we know disinfectants do. Now, also, one of the major differences between the two are the area by which it's done, where sanitizers usually are used in a public setting and disinfectants private, but we also know they can be used public as well. But sanitizers are known for their public usage, okay? Now, they both remove pathogens from inanimate objects. Also, with the sanitizer, examples of that are steam, scrubbing a surface, or high pressure hot water, which is a version of a dishwasher. So is steam. So that is used in restaurants to clean plates and utensils that we use. Also hospitals the same. Disinfectants have a different outcome and a different usage for that. So that's kind of how you can see the public and private setting there. Next we'll go over is antisepsis. Now this is the removal of microorganisms from the skin, as well as the reduction in flora in the skin. And what flora are they're responsible for in protecting the patient from infection by competing with the pathogen's receptors. So that's the biggest difference right there is antisepsis is used to treat skin and other tissue versus sanitizers and disinfectants are not. Also, antiseptics are very similar to disinfectants. The difference, one of the biggest difference we already said is that they're using skin, but also certain bleaches or steam that disinfectants use cannot be used on the skin due to the harshness of the treatment. Also, my stove's going off, I'm cooking dinner. Now, the chemical used in antiseptics are called antiseptics. Now, we're familiar with that. And some examples of that are iodine, which if you ever had sutures put in or any type of injection, that is the brown liquid they put on top of your skin to disinfect the area of treatment. Also, alcohol, which is used in the same environment. And alcohol must be used in a 70 to 90% range to truly be effective. We talked about that before. And last but not least is sterilization. Now, this is the removal or destruction of all microbes, including viruses and endospores, in on an object. Now, these can be used to remove and kill viruses and endospores, which we know disinfectants cannot kill endospores. Also, sterilizers are mostly used in healthcare settings because it can remove all microorganisms, which is extremely important in that environment. Examples of this are autoclaving, which is pressure applied to boiling water to prevent the escape of heat and steam. Ionizing radiation, which emits electron beams from atoms to create ions that can bounce off the microbiota or pathogens and kill them. And also dry heat. Now, incineration is the ultimate method for that, but dry heat is mostly used for oils and powders because they don't work well in moist heat settings. Also, an example of sterilization is commercial sterilization, which is used in canning. Now, canning is stored at more of a room temperature environment, and sterilization doesn't kill hypothermophils because hypothermophils don't survive in those type of environments. So that's an example of something that it doesn't kill. Now, one of the main focuses, or the focus behind controlling these microbial populations via these four options that we gave are is pathogenic microorganisms cause diseases. And if they're not controlled, that can lead to rapid reproduction, which leads to transmission and outbreak of serious illness. And we've talked about that before, where you have sensitive cells and resistant cells and antibiotics and other forms. A treatment can decrease sensitive cells, which causes rapid reproduction of resistant cells, and thus you have transmission. Also, pathogens that are not harmful to humans can still cause foliage in our food. And we also know there are harmful pathogens like E. coli, which can get into our food and harm humans as well. So thank you so much for your time. I appreciate it.